Okay, we're gonna talk about graphing technique and transformation, right? Graphing technique and transformation. So we are still dealing with function, right? We're dealing with the function, and in this topic, we are going to talk about how to graph a function, and especially using a transformation technique. Well, I guess what's the best way to graph a function? Well, I guess the best way to graph a function is using graphing calculator, right? If you know how to use graphing calculator, I guess that's easiest way. However, most of the graphing calculator has a small window. The units are not as accurate as what we want, and it's kind of difficult to actually correctly graph a function using graphing calculator, right? You need to really study the calculator as well. So we are going to talk about graphing a function using technical transformation. So basic idea is something like this. We start from the, one of those basic function from the library of function. Let's say if you have, say, f of x equal x squared. Right, at this point, I hope that you know what this function is called, and I hope you know uh, what this function look like, right? This is called square function, right? That's square, and it looks like basically um, this. I like the second part. Let's say something like this. It's supposed to be perfect U-shaped curve, right? And that function is called square function. Now, so if the questions ask you to graph this, then this is what you really should do. But what if we have another function, say g of x as x squared plus 1? Now, let me ask you a few questions. Why not f of x? Why did we change this to g of x? Well, the reason why we changed this to g of x is because we are dealing with a different function now. Remember this part right here, and same as this part, it's just a name. You can call it whatever you want. They usually use f because they are dealing with function, of course, but it could be anything. So now we are not using deliberately not using the same name because we are dealing with a different function. That's the only reason why we call this g of x. So let's talk about this g of x. Now what's happening in here? G of x is very similar to f of x. The actual difference is right here. Now to f of x, we added 1, right? What did I just say? To f of x, we added 1. So, I mean, if I really want, I can rewrite g of x as to f of x, I added 1 like that, right? Because what's f of x? F of x is just x squared, right? This is just x squared. So if we to f of x, we added 1, we are saying that's our g of x, right? That's our g of x. So this g of x is basically to f of x, we added 1. So when we add a number or subtract a number in the same sense, then what will happen to this original, see this red is f of x, right? Now, what will happen to this? Every dot on red is going to go up by how many unit? 1 unit, of course. right? Let me repeat that again. Every single point on f is going to go up by 1 unit. So see that point right here? It's going to go up 1 unit. See that point right here? It's going to go up 1 unit. See that point right there? It's going to go up 1 unit. See that point right there? It's going to go up 1 unit like that. So we'll have our new graph. Ooh, everything's shaky. Redraw it. So our new graph should look like this. Look like this. So from the red, it went up by 1. That's our g of x, right? That's our g. So, to a function, we have new function that's same, almost same as the original function, but we add or subtract the number. Then we move up or down by whatever the number is added or subtracted. So if this was a -2 instead of +1, what do we supposed to do if this was a minus 2? From the red, what are we supposed to do? That's right, we're going to bring it down by 2 units, right? Bring it down by 2. Well, let's do another example. So, example. Graph, say, g of x equal x squared minus 4. Okay. Again, you can see that from that original f of x function, we subtracted 4, right? We subtracted 4. So let's see. The original function, let's say f of x was x squared. This function, f of x. Now, our g of x, the function that we tried to graph, will bring this down by 4 units. So, extend a little bit. Let's say that's 4. So that should be -4 there, and it's going to go up like that, right? It's going to go up like that part. It's going to go up like that. Now, whenever that we are graphing a function, we really have to identify all the intercept, right? All the intercept. So, in our previous example, we didn't really, I forgot this. This should be 1 there, right? That point right there. See, but this one didn't really have any other intercept except this y-intercept here. But this one, we have one intercept here. We identified that as a -4, but we yet to identify these 2 points. These 2 points. So, this value is a y value, or we could say this is when we are graphing f of x function, that axis is going to be f of x. When we are graphing g of x, we're going to call that the usual y-axis as g of x, right? And this x-axis is not changing because the input value is always the x, right? Okay, so this and this, how do we identify these two? What do we know about these two? Well, we know this is x-intercept. Well, what do we know about the x-intercept? What's the main characteristic of x-intercept? Well, the main characteristic of these two x-intercept point is that y value is equal to 0. That's right. I mean, that's one of the definition of x-intercept, right? Y value is supposed to be 0. So how do we find this? Algebraically, you know that g of x from here, we're going to set that side equal to 0 because that's a y-x, that's y-axis, that's a g of x value, y value, same thing. We know that y value must be 0, so 0 equal to x squared minus 4. And we have to solve this. And at this point, I hope you know how to solve this, how to factor. I mean, you can use square root technique, but you can also factor this, right? So this would be x plus 2, x minus 2. I mean, e equals 0 is this side, but I'm going to move to the other side, right? Then from here, our x value, what value of x will make this equal to 0? Negative 2 and 2. So what should be this value? Negative 2. What about this value? 2. All right? That's the complete graph. Right? We identify all the axes, all the intercepts. Okay? All right. Another similar example, yet very different. Graph. Now our g of x this time is going to be x minus 2 square. X minus 2 to the square. Now this is certainly different from the previous examples. Right? What's the difference? Because all the previous example, for example, the change, the addition or subtraction was to not within the x but to the entire function. So remember here, to this one right here means to original f of x we added a number. Same thing here, original f of x we subtract the number, right? But this one is set it up differently. That minus 2 right there is not to the entire function, but it looks like it's only to the x. Our original function, let's say f of x is still x squared, but we're not subtracting 2 like that, right? We are subtracting 2 not to the f of x, but to the x. So our g of x looks like, let me rewrite it. G of x looks like x minus 2 squared, right? Certainly different from this, right? So when we add or subtract not to the entire function, but to the x only, which way should we move? Remember, when we add a number or when we subtract a number from the original graph, we went up or down, right? In this case, we went down because of that minus 4, right? But when we subtract or add a number to not the entire function but the x, now this is going to be, yes, x-axis move from left or right. But there's another thing that we also have to be careful. When we move like this, if it's a minus 2, which way should we go? It seems like it's going to go left, but that's not true. It's going to go to the opposite way. So if it's minus 2, then we are going to go to the right. If this was a plus 2, we would have went to the left. Right? So let's try to graph this. So let's say original f of x looks like this. Now to that, because of that minus 2, we are going to move to the left by 2 units. So it's going to go 1 and 2 units. So that's going to be plus 2, and it's going to go up like that. Right? It's going to go up like that. Okay. Now remember, if it go up, let me just extend a little bit here. This will cross at that point, right? Cross at that point. We have to identify this point. We know this point because that's a plus 2. What about this point? What do we know about this point right here? That's a y-axis, y-intercept. What's y-intercept value? X equals 0. I mean, it makes sense. I mean, it's right above the x equals 0, right? So when x equals 0, what do we get from this value, right? When x equals 0, in a way, we are looking for g of 0. So replace x by 0, we have negative 2 square, which is 4. Negative 2 times negative 4. So what should be this value right here? That should be 4, right? At 4, this red line is crossing the y-axis. Okay. Let's do one more. Almost the same concept. Graph g of x. This time is going to be x plus 1 square. Okay. So now that we tried, I want you to pause this video and try it on your own and see if you can graph this. All right, so let's try this again together. So the original f of x graph square would be something like this. I don't like this line. Gotta be a little bit skinnier. This. Okay. Now, because of this plus 1, not to the entire function, but to the x. Now, this red line is going to be shifted to the left or right, or up or down. What do you think? Because it's to the x, it's going to be at this horizontal move. And because it's plus, it's going to go to the left by 1 unit. That's right. So that point right here is going to go left by 1. Let's say this is 1. So that point is going to be negative 1. And it's going to go like this. Now we have to identify this point. This point is what? X equals 0. So when g of x equals 0, what is going to be? It's going to be just 1 square, which is just 1. So that point must be just 1. And that point is going to be negative 1. And that's our new graph. Right? That's our new graph. All right. We can also do combination of this. We can also do combination of this. So graph, say g of x equal x say plus 3 square minus 5. Okay, again, try to do it on your own. See if you can do this. Then we'll check the answer together. All right, so this one would be to the original f of x, which is x square form. Now, to this x, we are adding 3, but also to the entire f of x, we are subtracting 5. So this plus 3 will do what? Which move? Left or right, up or down? To the left 3 unit. What about this minus 4? Up or down? This would be down what? Down 5, right? From where? From this original f of x. So let's see. Since we're going to go down by 5, let's make our graph. Looks like, say, down left, looks like this. Okay, so the original f of x looked like this, right? Oh, don't like it. A little bit prettier. All right, that's a little bit better. Okay. Now, this will be moved to the left by 3 unit, down by 5. Which one should we apply? Does it really matter? What doesn't really matter? So let's say it's gonna go to the left by 3, so it's gonna go 1, 2, 3. So at the moment that's going to be -3. Now it's gonna go down by 5, so it's gonna go 1, 2, 3, 4, 5. So that point right there is going to be -5. And we are going to make this U-shaped curve. Now it's going to go something like this, right? Something like this. But we also want to check the y-intercept. So we want to set g of 0. Right? So if we put 0 in here, then it's going to be 3 square minus 5, which is what? 9 minus 5, which is 4. So we know that it's going to pass, well, we extend this point, this line, and let's say that's 4. It's going to pass that point. It's kind of difficult to graph, but I'll do my best. It's going to hit that 4, right? And it's going to go up like this. All right. It's a little bit not natural, but you get the point though, right? It's going to hit that point 4, and that point is going to be x equal -3, y equal -5, like that. Okay. And let me just ask you one more question. Would you say this would be the minimum point of that graph? Yes, of course, because it's going to go down up to here and it's going to go up. It'll never come back down. So that point right there is going to be the minimum point. The minimum point, right? Okay. Now let's do a few more things that will be done. Now, there is another transformation technique which is called vertical stretch. Vertical stretch. What do you think it means? Well, it means, as it says, you are stretching it out vertically. Or you're stretching it out vertically. So, let's say you have this original function, f of x as this. Now, does anyone recognize this function? What do we call this? Remember in some of the previous lecture, we talked about this function. This is called the absolute value function. Absolute value function. And it looks like this V shape. Right? So for the reference point, let's say if this is 1, that's going to be 1. Right? It's a V-shaped curve. I mean, not curve, straight line. Right? V-shaped graph. Now, let's say you have g of x, which is 2 times 2 f of x. If you multiply, remember in our previous transformation, it was just always adding or subtracting a number. What if we multiply like this? Multiply 2. Then this is going to be vertical stretch, meaning you're going to pull this graph this way, this way. You're going to stretch it out. Right? You're going to stretch it out. You know what? I'm supposed to graph this original line with the red. So let's say this is red. I'm going to overwrite it. Well, you get the idea, right? This is the red graph. Now, if you stretch it out vertically, this 2, what does this 2 will do? This 2 will stretch this graph vertically, like this way and this way. So this g of x graph will look like, I don't like this line, right about this. Up. Let me try again. Okay, that's good. All right, that's good. So this new yellow graph, the g of x graph, should look like this. Of course, it's not going to be this messy graph. It's going to be nice one-line graph. So that's going to be g of x. So that point right here, the minimum point didn't change. But see, when x equal 1, the previous case, y was 1. For this one, when x equal 1, what's g going to be? The y going to be 2 times absolute value of 1, which is 1. So 2 times 1 is 2, of course. So when x equal 1, now that point right here is going to be 2. Right? That point right there is going to be 2. So when we are multiplying a number bigger than 1, let me repeat that again. When we multiply a number bigger than 1, not smaller than 1, not negative, bigger than 1, then it's going to be vertical stretch. Right? Vertical stretch. Okay. Now there's also another one called vertical compression. Vertical compression. So what's vertical compression? You are compressing vertically. So let's say our g of x this time is going to be 1/2 times of absolute value of x. So let's say to the original f of x as absolute value of x. Let's say it looks like this. Oh, this horrible line. Supposed to be a straight line. Okay, and I guess one of the reference points should be 1 and 1, right? That point right there. Now, because of this number that's been multiplied, but this number, unlike the vertical stretch, is less than 1, right? Less than 1. Because it's a less than 1, now this original graph is going to be vertically compressed. So this g of x graph, so remember this red is original f of x. Now this g of x graph is going to look like this, compressed. So let's check out this reference point. When x equal 1, if you put 1 here, what's y going to be? Half times 1, half. So supposed to be 1/2 right here. And the yellow graph is g of x, vertically compressed graph. Okay. There is one more that I like to discuss is reflection. So reflection about the x-axis. Reflection about the x-axis. Let's say we have g of x that's minus of x squared, right? Minus of x squared. Now this is different from to the x only we are taking minus. We are taking the whole thing, the entire function, which is original function f of x, then we took minus. Then let's say f of x was x squared, then it's going to reflect the original graph around about the x-axis. So let's say the original f of x, U-shaped curve like this, the new g of x is going to look like this. So g of x is this. As you can see, it's a reflection about the x-axis, right? So when you are taking minus to the entire function, then it's going to reflect around about the x-axis. Okay. Now another topic is reflection about the y-axis. Reflection about the y-axis. So new function, let's say the original function is square root of x, and new function is square root of negative x. Okay. Now, don't like that line. A little better. So the original f of x was square root function that we know it looks like this, right? Now, this g of x is different from, let's say, another function h of x. This g of x is different from, let's say, another function h of x, which is negative of square root of x, right? If we have something like this, negative to the entire function, that would be this case. So it's going to be reflection about the x-axis case, which is you flip around the x-axis. This case, you're not taking minus to the entire function, you are taking minus to the x only. Then, if that's the case, it's going to be reflection about the y-axis. So this red graph now is going to reflect about the y-axis, so it's going to be something like this. So this is this. Well, while we are at it, let's also graph this h of x. If we have h of x, let me use different color. Let's say this h of x would have been what? Reflection about the x-axis. So this original graph would have been what? Reflect like this. Like this. So this would have been this, right? Okay. So we checked several different techniques of graphing a function using transformation, right? You go up and down, left or right. You can do vertical stretch, vertical compress, and you can also do reflect about x-axis and also the y-axis. All right.